Hello, I am Marla May, and today I will be teaching you about limits at infinity and horizontal asymptotes. First off, what is a horizontal asymptote, you may say? Well, a horizontal asymptote occurs when the limit as x approaches infinity of a certain function equals a certain number, r, or the limit as x approaches negative infinity of a certain function, f of x equals r. So what that means is when x gets really big or really close to infinity, that function will always equal a certain number r, and it will never cross that number. So first, I have an example. Find the limit as x approaches infinity of 1 of x and the limit as x approaches negative infinity of 1 of x. So what you have to do here first is plug in a really big number because x is approaching a really big number in infinity. So I plugged in a really big number for the first equation, 100, 1,000, and 10,000. And that got a really small number. Very close to 0, as you can see. Next, it was also the same with the negative. If you plug in a really big negative number, it will get you a really small number, even though it's negative. So I plugged in negative 1,000, 100,000, and 1 million, and look, you get a really small number, very close to 0. So based on that conclusion, and the definition of a horizontal asymptote, you can conclude that as the limit x approaches infinity for the equation 1 of x, that will always equal 0, and the limit as x approaches negative infinity of 1 of x, that too will also equal 0. This brings me to the theorem. If r is greater than 0 and r is a rational number, then the limit as x approaches infinity of 1 over x of r equals 0. Because if you plug in any number that's not 1 in x of r, because it's approaching a really big number, that will always be more than the 1 in the numerator, and it will always be close to 0. And also, if r is greater than 0, and it's a rational number, so x of r is defined for all of x, basically meaning it's continuous, then the limit as x approaches negative infinity of 1 over x of r equals 0. Because x of r is always continuous, it always has a number there, so 1 over that number will always be very close to 0, and it will be very small. So this brings me to my example. Find the limit as x approaches infinity of x cubed plus 5x over 2x cubed minus x squared plus 4. Well, to evaluate an equation at infinity, you have to multiply the numerator and the denominator by the highest power of x in the denominator. So, as you can see, it's x cubed, and you divide each value by x cubed. So then you have to simplify. I simplified here. That simplifies to 1 plus 5 over x squared over 2 minus 1 over x plus 4 over x cubed. And then, using the limit laws, you can distribute the limit to each value. So then you can evaluate it on your own. So if you evaluate the limit as x approaches infinity to 1, you always get 1. So after that, you simplify to 1 plus 0 over 2 minus 0 plus 0, which simplified basically is 1/2. Next up, we are looking at limits at infinity. So my example here, to find the limit as x approaches infinity at x cubed and the limit as x approaches negative infinity at x cubed. First, with the x cubed problem, you plug in a number for x that's very close to infinity, like 10, 100, or 1,000, and you get a really big number, like 1,000, a million, or 1 trillion. Same goes for the negative. If you plug in a negative number, you get a really small number though, negative 1,000, negative a million, or negative a trillion. So based on that conclusion, the limit as x approaches infinity of x cubed equals infinity, and the limit as x approaches negative infinity of x cubed equals negative infinity, because no matter what number you put in for x, it will always be greater than the original number you put in because you're cubing it, and it will always approach the number infinity. So here is an example. To find the limit as x approaches infinity of x squared plus x over 3 minus x. First, you got to divide it again by the largest power of x in the denominator. So that is x. And then you simplify to get x plus 1 over 3 over x minus 1. And then after that, use the limit law to evaluate each value as x approaches infinity, and you get infinity over negative 1, because if you plug in infinity at x plus 1 will be infinity, and at the bottom 3 over x, if you plug in infinity, that'd be 0, minus 1 would be negative 1. Simplify that, you get negative infinity. And that, ladies and gentlemen, is limits at infinity and horizontal asymptotes.